Okay, so this video will be on question 2.8. Okay, so for this one, we have PQ and BQ. They are tangents to the circle. So this is PQ and BQ, right? They are tangents to the circle with center O and radius 3 cm at point A and B respectively, meaning that this is also 3 cm. Now, given that POA is equals to 50 degree, AOB is equals to 60, and we have tangent 30 degrees equals to square root 3 over 3. I don't know what this is for, but let's find out later. So next, we need to find out what's angle OPA. Now, part A actually is very easy because if you just observe, right, you can see that with the tangent perpendicular to radius, right, you can see that angle OAP is 90 degrees, right? So looking at this triangle, right, we just take 180, subtract 50, subtract 90, we can find out what is OPA. So first, let's write down angle OAP, right? Angle OAP is equals to, okay, some of you say don't use green, that's why I can use green. Okay, so it's equals to 90 degree because tangent perpendicular to the radius. So after I know that this is 90 degree, right? Looking at the blue triangle, I'll have angle OPA to be equals to 180, subtract 90 degree, angle OAP, subtract angle AOP, 50 degree, which gives us 40 degree. Okay, so from there is also the angle sum of triangle. Okay, so that is part A. Now for part B, right, what this requires us to think a bit. So first of all, we know that tangent from external point, that means these two lines will be equal, right? So what I'll do is I draw a line in between. You know that if I look at OBQ, right, OBQ, this triangle will be congruent to OAQ as well, because they basically both have 90 degree. These two will be equal because of tangent from external point. These two will be equal 3 cm. This will be equal. These two triangles are basically congruent. So with that, right, you can conclude that this angle here, angle OBOQ is 30 degree. Angle QOA is also 30 degree. Okay. Now angle BOQ is equals to 30 degree. So what does that tell us? That it is first of all, if I want to find area of quadrilateral OAQB, I'm going to start by finding perhaps OQB or OQA, and then I'm going to take area of OQA, and then I'll multiply by 2 to give me the area of quadrilateral OAQB. So first, how do I find, I know that I'm thinking of half AB sine C. Okay, so half BQ, first of all, okay, I know what is OA, this is 3, this is 30. I can use this to find my QA. Okay, so by using Tuakaso, right, tangent 30 degrees, right, will be the same as QA over OA, equals to QA over OA. OA is equals to 3 cm, meaning that QA is equals to 3 of tangent 30 degree. Now earlier we know that tangent 30 is square root 3 over 3, right? So this is 3 times square root 3 over 3, which is square root 3 cm. So it tells us that this is square root 3, this is square root 3. With that, this is also 90 degree, right? So if I want to find this triangle here, I can think of it as half times base times height. And if I want to find the entire segment here, right, the entire part here, OAQB, right, I just need to multiply by 2. So my answer here, B, will just be 2 multiplied by the area of triangle OQA, which is 2 times half times base times height. And the answer turns out to be just equals to 3 square root 3 cm squared. Okay, with that, we are done with this question. Thank you.